Good morning. That was a very interesting conversation with Backblaze. It's actually a very nice segue into my presentation because a lot of the things that Gleb mentioned is actually the reasons why we're seeing a lot of transition of hard drive-based systems moving over to flash. What you're seeing today is pretty much a transition where in the past 2-3 years, a lot of the storage array vendors have moved away from the 15K and 10K drives to move to flash. What we're now looking at is a transition, and I'll go through this in details on the reasons behind it, of why systems are now looking at flash to replace even the big SATA drives. So standard legal stuff. So the first thing I wanted to talk about is the speeds and feeds of different things in the infrastructure, because it really makes a difference on why you want to deploy flash a certain way. So when you look at the technology, a single gigabit Ethernet is about 80 megabytes per second on a non-congested network. You can get higher in certain cases, but on a traditional IP-based network, that's the average you'll get. 10 gigabits is about 800 megabytes, 25 gigabits about 2, 40 is about 3. And then when you look at hard drive, enterprise hard drive and cloud scale hard drives, I'm giving them a benefit of the doubt because in a purely sequential read-write workload without interrupts, they could easily hit up to 200 megabytes per second. But in a mixed workload environment, you'll be lucky to get 30, 50, maybe even 100 megabytes per second. And again, latency, 4 to 6 milliseconds, about 200, 300 IOPS. And again, based on activity, 0.73 AFR. A lot of the previous speakers have talked about this, and it makes sense. In the protocol world, when you look at 6G SAS SSD, 12G PCIe, and so on, 6G SAS is about 550 megabytes per second. Reads are probably at that level writes because of flash issues. You're slightly below that. But the thing about SAS is you have dual-ported capabilities. So if you had a SAS device that can dual-port, not just for pathing, but for performance with your correct controller, you can get double that throughput. When you look at 12G SAS, you're about 700 gigabytes, that's not megabytes, I mistyped that, to about a gigabyte per second, again, per port. And the latency isn't as bad as people think. Everyone keeps saying that the SAS bus latency is high. Well, the stack above it, when you take a SAS device and make it all going to RAM, you're sub 100 microseconds. So when you start looking at some of the newer 12G SAS devices, you're going to see sub 200 microsecond latency through that bus. And then PCIe NVMe devices, 800 gigabytes to 2 to 3 gigabytes per second. Again, it's related to the PCIe bus. You can get faster. The latency is about 50 to 200 microseconds. Again, it's related to NAND latencies. You actually can get slightly better latency. That's tricks that people play. And then SATA drives about 500 gigabytes or megabytes per second. Sorry about that. So when you look at the speeds and feeds comparison, 6G SAS compared to SATA, you're about 2 to 3x. So when you look at filling a 4 terabyte drives, you're looking at 2 hours versus 5.5 hours. When you look at 12G, it's 1 hour versus 5.5. 12G to 6G SAS, you're 1 hour versus 2 hours. When you look at PCIe to hard drives to so on, the differences are dramatic against HDD, but when you're looking at PCIe NVMe to SAS and SATA, not so much, and that's not looking at dual-ported capabilities at the moment. And then the transport, when you're looking at the fill times for 2 terabytes over those transport layers, you're looking at a very interesting trend, because a lot of the AFR calculations, a lot of the reasons you do erasure coding at +2, +4, +6, whatever, is related to repair times, related to how long does it take to go back to operations, to rebalance your system. And when you're looking at something like Hadoop, which is more of an active storage bus versus a archive storage bus, which is what Backblaze and Shutterfly are talking about, when you're looking at active analytics, either batch or near real time, when a hard drive fails, it's about 15 minutes for a 2 terabyte drive. As you increase the capacity of the drive, you're looking at how many hard drives. When you look at 10 gigabit pipes, 4 hard drives, about 40-minute fill time for 2 terabyte drives. That's assuming one pipe into that server with multiple things trying to feed it to fill that 4 terabyte drive. Now, the good thing about Hadoop is it's a many-to-many, but it's still, unless you go to MapR or things that uses erasure coding, which HDFS 3.0 is moving towards, it's not truly a many-to-many. You're still moving large blocks, but you are going to different drives, not just the same drive. So when you start looking at these different changes, what you're starting to see is that when Hadoop started a couple of years ago, a gigabit network was pretty much the norm. And 80 megabytes per second, when you go back here, is extremely slow when you look at a SATA drive capable of doing about 200 megabytes per second locally. So when you put 4 in a device, it's much faster to do that capability than it is to move the data from a disaggregated storage to that local server. But as you move to 10 gigabit networks and faster, people are now looking at not necessarily keeping the data local to the compute, but having the elasticity of being able to move the compute and move different use cases onto the compute. One of the trends we're seeing is when a couple of 3-letter acronyms talked about data lakes years ago. The problem with the data lakes back then was it's high capacity, but very thin streams of data going in and out. Now that you're going for higher transport speeds, you're now able to fill an in-memory database, a 2 terabyte in-memory database in very little time with the right amount of media and network pipes. Your 2 terabyte in-memory cluster, where you have a cluster of maybe 12 servers or even more, you can fill it with the right infrastructure in a very short period of time, measured in minutes and not necessarily hours in the past. As you look at the gigabit to fill 2 terabytes, that's about 7 hours. But when you start looking at much lower, at 25 gigabit, you're at 15 minutes. At 40 gigabit, you're at 10 minutes. So what we're seeing today is that consumer-grade flash is in the 35 cents street price range, 35, 40 cents. You can see that, the 2 terabyte Samsung 3D NAND, Sandisk 1 terabyte drive, the 2 terabyte drives, SATA are becoming prevalent. That's relatively inexpensive. The prosumer drives at that price point, when you look at erasure coding on top of that, you're looking at potentially, at a very wide striping of about 15% overhead of something like a 15 plus 2, you're looking at maybe 50 cents. 50 cents a gigabyte for the storage. Well, actually, it's about 60 cents a gigabyte for the storage local to a server, all flash. And what the reason for that higher cost is the fact that the 2 terabyte SATA prosumer drives are still low enough capacity that the cost of the compute is a larger portion of that. But as you've seen, Sandisk and our competitors have come out with 8 terabyte drives, 4 8 terabyte drives, and 16 terabyte drives. At the amount of about half a petabyte in a chassis, every compute that costs $6,000 to $12,000 is only a 3 cents adder to the price per gigabyte. So as the price goes down on flash, and I can't quote you where these SAS-based devices are, the actual cost for having a large pool of storage is aggregated through a network that can now move the data to the compute correctly. As you look towards the future, it's now at a point where it's rivaling a 3-copy hard drive model of Hadoop. So when you're landing 3 copies at you're thinking, everyone's thinking, oh, but enterprise SATA drives is 6 to 8 cents a gigabyte, maybe down to 4 to 6 cents a day. But when you amortize the compute on top of that, you're at the 15 to 25 cents, depending on your procurement power. And some people who doesn't buy large amount of servers in hard drives, they're at the 35 cents per gigabyte. When you look at the capacity play with the server, you're now looking at a 60, 70 cents with a ratio coding 80 cents, just looking at the prosumer drives. At that level, compared to a 3 replica copy, the performance, and I'll have links at the end of this presentation where the performance on these types of devices is 3 to 6x for IO intensive, shuffle phase in Hadoop. And when you start looking at where the data is landing, more people are landing data to either a large distribution of a hard drive, and now we're looking at people landing it to a smaller distribution, but it's still a very wide distribution of flash feeding a compute farm. And that compute farm also has flash inside, but a different quality flash. And the flash inside is meant to extend memory. But what you're going to see, and I'll touch on this more, is that in the next 3 to 5 years, we're seeing a transition as Intel's Crosspoint and Sandisk and HP's venture in ReRAM is going to move the bar as you're getting in-server memory extension technology that are non-volatile, that are way faster than what NAND can do, at a price point that is not equal to the cost of memory. It's significantly cheaper, but still not cheaper than flash. So what we're seeing is a trajectory where flash is becoming a throughput play that will match the networking as photonics is coming in, as these faster, 12G, 24G SAS, NVMe, faster, wider PCIe data buses. You're starting to see throughput driving into active archive, driving into active data, sensor analytics, these things where you now are saving sensor analytics not just to sit there and then pull it out to analyze it, but to sit there and analyze it and then tail it down to the lower cost SMR drives, because at that point it's written once, and the only time you access it is when you need to read it because of an event that exceeded your value over time. And I'll touch on that a little bit more. But the value that we're seeing is the fact that people are getting more out of their storage. There are real-time applications that are getting value by putting flash local to the system, but even today, 10K, 15K drives are less valuable because of capacity constraints, where flash has now greater capacity. We're now at 2, 4, and 8 terabyte flash in a 2.5-inch form factor. And endurance is becoming less and less of an issue as the technology and the understanding and characteristics of flash is becoming more of the norm. People now know how to take advantage of that at the software layer. So what you're seeing is, and this is a message of today and the next 2 to 3 years. What you're seeing is that flash is moving into the servers for real-time and near real-time capabilities. You're seeing disk drives, they may still be there, but I know a lot of cloud vendors at scale, and the hyperscalers are the first to hit the transition to flash. They see the value of having flash local to the server. And it's a lot of times it's because of cloud, a lot of times it's because of the way they have to allocate resources. And it's easier to hold a smaller amount of resources, of resource SKUs, than it is to have a large amount. I mean, at eBay, I went from 194 SKUs to less than 10 SKUs when I was there to help reduce the operational cost of maintaining everything. And when you start looking at this, databases were the drivers for putting flash into it, and now cloud is the driver for putting flash into the servers, our own virtual private clouds. And we're seeing this, again, as part of Sandisk. I left eBay about 2 years ago. As part of Sandisk, I'm now seeing this transition, not just at hyperscalers, but at scale-out enterprises going across the board. And batch analytics, as I said, one of the challenges with Hadoop in large storage, active storage buses, I want to make a distinction between active storage buses versus archive buses, where you're looking at deep archive or even cold archive. When you're looking at batch analytics and near real-time analytics, several things happen which really, in a white paper, hard drive looks great because of the claims that one of my Hadoop friend used to say is that, Hadoop is purely sequential read and writes. And for hard drives, that's perfect, except when violated by log files, shuffle file, ingest, repair. And at scale, when you're at 30 petabytes plus in those types of analytics, every bit of that I just mentioned, those noise happens all the time. So when you look at your active analytic environment, whether you're feeding e-commerce or things that are, service-based analytics, and I want to make a distinction because when you start looking at very dedicated analytics like search, you won't have that problem because it's a known quantity and you could design for that. But when you're looking for things where you're serving data scientists and they have a bunch of different requests that's coming out and they're looking at data. You can't tell a data scientist you can't look at a certain data. If that data is like 9 years old, you can't tell them, no, I don't have access to that. You have to provide it to them. So when they look at things and says, I think we can get a 3% GMV lift if I look at people's shopping trends from 9 years ago to now, and what are the things that they buy seasonally. And when we've done this at eBay, we've seen 2 to 3% GMV lifts after these types of analytics happen. When you see 2 to 3%, it may not seem much, but when you're talking about a $6 billion revenue stream, I'd love to get 2 to 3% multiple times. So when you start looking at these types of batch analytics, the ingest rates, the dropout of ingest because of the long tail issues, the stalled analytics because of the ingest slowing down the things, is driving a lot of people for two things. The first one is to put a flash layer. And this is one of the reasons tiering in Hadoop is becoming interesting, is that a lot of people are seeing that in an active storage bus, anywhere between 5% to 30% to even 40% of the data is active. And then the rest of the data is less active. And I want to make a distinction of less active in the fact that less active means they may not be touching the data, like writing it, but they may be reading it seldom. They may be asking maybe for the piece of data there once a week, maybe once a month, maybe once every several weeks. But in the first X months or X weeks, that data is being churned regularly. So when you start looking at that type of data access, tiering in active data buses is now making people move to a flash environment because now your entire analytics aspect speeds up. The 3 to 6x performance gain, from 20 minutes taking down to 4 minutes. And when you're looking at a 6-hour job, taking it down to 2 hours or even 1 hour is significant, especially if you know that every 8 hours you have a batch process that comes in that makes a long tail. Well, flash has less impacts to writes when it comes to ingest than hard drives. When the hard drive starts doing reads and writes, because you're doing analytics and there's space available and you're starting writing to it, your hard drive is going from 100 megabytes per second, and now you're having log files and transient files, and now you're having ingest file. Your queue depth has just gone from 1 or 2 to 4 to 6, and at 4 to 6, each of those are now getting about 30 megabytes per second. And at 30 megabytes per second, your 100 megabytes per second assumed throughput has now dropped to 30. And so your job has gone from 2 hours to 6 hours. And again, in a hyperscale environment or in a mixed environment where you have data scientists going and asking these questions, what you get is the same thing you get in virtualization, which is a blender effect. You don't know what questions they're going to ask, so you can't really place the data correctly. A lot of times the data, because of the way these storage environments places the data, where they prefer the free storage first, and so the data lands on 4 racks, then you add 2 more racks, and your data lands on those 2 racks. But if I'm asking questions that's spanning the width of time, a lot of the times the first jobs land on those 4 racks. And then my other questions, the analytics, are now running on the 2 racks where the data is still on those 4 racks, and now the network becomes a bottleneck. So when we moved from a gigabit Hadoop network to a 10 gigabit network, we saw 9x performance gain because of that anomaly. So again, the reason a lot of our customers are moving to this is the fact that they're moving from a 3 replica model down to a 2 replica model to get cost. It's still 30% of the cost of a 3 replica hard disk model, but it's actually more than 30%. But it's still, when you start looking at that, the value that they get for the fact that it's 1/7 the repair, the fact that flash is 4 times the throughput, as well as 0.15 AFR compared to hard drives, which is 0.73, what you're seeing is that the weekly sweeps on petascale environments are now dropping when they move to flash to quarterly or even semi-annual sweeps. And the other aspect, which I'll get to at the end of this, is the fact that the power, the TCO versus the TCA, you actually reclaim the TCA cost, the 30 to 50% increase in cost, by the TCO in places that are real estate and or power constrained. And a metrics I did not put up here that would be very interesting is the fact that when you look at amortizing the cost, the TCA cost and the TCO cost, so that you're taking your service that you're creating for your own private environment, and you're comparing it to Glacier, which is, again, a penny a gigabyte, let's just throw that out. Amortizing it for 3 years to 5 years, a flash-based solution like InfiniFlash, you're below a penny a gigabyte. And you don't have to pay anybody a cost to read it. And a reason for that is because of the operational reduction, the manpower reduction, the operational fatigue reduction of the fact that you're not going weekly repairs, you're not going, you're going semi-annual repairs. You're failing 1 flash unit in an annualized repair rate. You're failing 1 versus 35 at about a 80 petabyte scale. So again, one of the things I keep talking about, and it's getting a lot of resonance in the area, especially when you start looking at how people do commerce, how people do things like geographic analytics and so on, is the fact that with WAN, everything in the data center is going faster and faster, but the WAN is not going as fast as the data center. So everyone basically says, let's say you're Walmart and you have all these stores. The stores has to send the data to the main data center or to a edge location, or I'll give eBay as an example. If you have a kiosk that's sending out information, and now you have to take that information, which gives you people who's connected to you, the people who's local that you've sent information on. You either it's a kiosk or it's a store like Target's or whatever, and you've got this information from PayPal. You need to take that information, bring it someplace closer to your data center, then reduce the data and then bring it into your data center. Because as you move the data from the edge to the near edge, all that data is pertinent, but you can't move it because of the WAN. So you have to reduce it, move it to closer to the core, and as you get closer to the core, you lose fidelity, but you keep the data that you care about. So you may drop all the personal information, but you might keep, what did they buy, their age group and whatever, and then they move it closer. And as it gets into it, now you have the ability to look at inventory within a geography, inventory globally, and shopping trends and do analytics on it, to the point where when someone goes into a store, you could tell them that guy bought X, Y, and Z because you have that local capability. And you can't do store level analytics today because of the performance and cost of hard drives. They only have half a rack in a lot of stores. But with half a petabyte in 3U and the ability to do analytics in a virtual environment and using disaggregated analytics, where the storage for the data being stored and the analytics engine is separate, you're able to do these things in store and respond quickly. So if you know he's buying something and there's a sale of the same product, you may be able to send it to him. And again, that data lakes model is something that a lot of the scale out companies, we're talking to them, some of them are moving to hard drives, and then they look at the flash, so they're now looking at moving to all flash. So this is InfiniFlash. So this is actually not updated to our newest one, which we just announced. You know, I claim 1/10 AFR hard drive. I'm giving the hard drive 0.73, even though at active active storage bus, it actually has a higher AFR. When you're really not writing and reading from it much, the AFR does stay at 0.73. So in this, 20 hard drive failures for every InfiniFlash card. You get 5. So here's another interesting thing. When you compare 8 terabyte hard drives to this flash device, you're thinking, I got 8 terabytes of usable data. Well, guess what? Because of right sizing and the way they calculate capacity, you get 7.6 terabytes or 7.2 terabytes of data you can use. With InfiniFlash, when we say it's half a petabyte, we give you 500 terabytes of usable flash that is fully available to you. Aggregated across all the flash cards, we can do 2 million IOPS. Again, it's based up to the software stack. And one of the software stacks we really like, and we've actually done a lot of work in, is Ceph. Because with Ceph and wide erasure coding, what we've seen is we can take the latency time of an object store on this device, move it to erasure coding versus replication, increase the compute core usage by about less than 10%, but we're now built in the low 2-digit millisecond response time. And with about the same throughput. So this box can do about 8 gigabytes read and 6 gigabytes write. Per chassis. Our new chassis is actually 12G, and we're able to do 14 gigabyte reads and about 8 to 12 gigabyte writes. But you're able to get that throughput with Ceph, or within 80% of that throughput with Ceph, with erasure coding, with just a little bit more use. In fact, when we did Ceph block with Cinder, we're able to stay within 2 millisecond response time on flash with a 2 replica model. We're actually contributing an erasure-coded block model for this so that the price on Ceph on this type of flash will be below $1 a gigabyte by the end of this year. And you now have a block model that can give you 2 millisecond read-write latency. That's relatively on par with most storage arrays today. Oh, and by the way, a lot of the questions people ask is, what is the endurance of your card? We don't look at a card level endurance because this is a system. What we look at is basically the amount of data you can read and write from this is about 2 to 3 exabyte of change rate. And let me speed up a little bit. So here's where you compare disk with flash. When you look at active archive, you can put 15 InfiniFlash in a standard 42U rack with 2 servers, and when you compare the capacity versus hard drives will have 4 petabytes raw. InfiniFlash will have 6.8 petabytes raw within a 40U rack with 2 servers with a bandwidth of about 255 gigabytes per second. This is again our previous product, double that for the 12G SAS product. With hard drives, about 30 gigabytes per second, 30 kilowatt idle, 7 kilowatt all active versus hard drives that are 9 kilowatts idle and goes up as you increase activity. On the data lake model, again, with a 70/30 workload, you're at 4 to 6 petabytes. This will be available. You can take a look at this. But when you start comparing that with a hard drive-based system, the question you're going to ask is cost. Well, yes, flash will be more expensive than hard drives. That's going to be true for the next 3 to 5 years. But as you look at this, the acquisition cost of our InfiniFlash with erasure coding versus a traditional 3-copy Hadoop, we're within 30-40% of the price. But when you look at the red, which is the total cost of ownership, the density and the power, actually the power is actually what saves a significant portion of this. One other aspect that became very popular in APAC is the fact that a half a petabyte of this box is only 100 pounds. So it doesn't kill you trying to rack it up if you've ever done any racking and stacking. Again, sensor analytics, value over time. At the moment, this is all hard drive. But what we're seeing is moving to the high value area with real-time analytics. Flash is making a big play there. At least customers are looking at flash for that area. And then SMR drives to cost reduce it down to a significant reduced cost. Again, seasonality. This is another problem where you do a lot of analytics. You want to move your servers because you don't need it to do this type of work all the time. You want to be able to move it to do something else to give you higher value. And during the time you have the seasonal peaks, you want to move the compute into it. So in this model, outside of Q1 and Q4 and Q3, everything is running web tier. This is all the e-commerce stuff. But in Q1 and Q2, when everything drops, you can then move the server because all the storage is in your data lake, in your Hadoop data bus. You can move the servers in your analytics engine into, you can move it from your web tier into your Hadoop environment to do more analytics. Again, edge to core we covered. So what we're seeing is that the larger 4 and 16 terabyte drives is actually helping push the transition of hard drive being displaced to longer tail, where flash is now the front end. And as we see the cross point and so on, we're seeing basically 4 lines, and I'll end it with these 4 lines. The first line is going to be in-memory, non-volatile. The second line will be high-performance IOPS, either disaggregated or local still, as a storage media, not as a memory extension, where that is currently being used as memory extension. And then you have the high-throughput flash, which you're going to see a lot more of, that is optimized for the big data buses, for feeding data in and out of these pools. And then you're going to see tape and hard drives as the longer tail with SMR. And again, the rest of this, flash performance perspective, Barcelona Supercompute, Sandisk has some of the things, and these are 2 SSDs versus SATA plus SSD plus SATA drives only. And again, more, this will be available so you can take a look at it later. Thank you.